and see if it allows you to record now.
I'm recording right now.
Okay, awesome. And you have space on your
Yes.
All right, awesome. Thank you, Natalia. Lifesaver. Okay, so we can. I mean, is everybody still good to well, pause the recording, Anna, because I don't want it to be taking. If you like, Anna. So this lesson is on 29, note number 29 for the pre-calculus. This is vector situation. So now we're applying vectors. Next time, I see some of y'all. I see y'all don't have your video on. So next time, if you just prepare next week, I would like for us to have our video on so I can see y'all and have feedback. Okay. So if you need to put your makeup on, whatever you got to do, if you don't feel comfortable, I would like to have your video on because I would really like to see y'all. Okay. So that's what we're doing today. All right. So a couple things about topics for this week. So as a reminder, we're not doing a lesson tomorrow. We moved that to today because y'all voted on doing that. And so we're doing 2 lessons in 1 today. And then I will still have Zoom office hours on Thursday to answer questions on the practice that I posted for today's lesson, okay? And you had an IXL from Monday's lesson that you were to do by Thursday, okay? And then there's no school on Friday, there's no school on Monday, so the next formal lesson we will have will be a week from now on Tuesday, okay? All right, so we'll go ahead and get started. As always, we say our 4 goals. If you want to unmute yourself and say it with me, you can. Or you can say it silently or in your head, whatever. We will learn math, build character, never give up, and ask why. All right, awesome. So this is one of the word problems we're going to look at today. So this is an example of applying vectors. Can someone read this for us, please?
Juana and Diego were 2 little kids who decided to take their big dog for a walk, so they used 2 leashes. If they pull with the forces 23 pounds and 27 pounds at the angle shown in the figure, what would be the direction and magnitude of the resultant force?
Okay, thank you. So we have a dog that is being pulled by 2 leashes in 2 different directions with different forces, okay? And what we're trying to figure out is if they're both pulling, what is the resultant, the addition of the 2 vectors, right, is what resultant means, of their forces. So combined, which direction would it go and by how much force? Okay, that's what we're looking at here. There are 2 vectors in play here. First, I want you to make a prediction just based on what you think. So the first question is, before the prediction actually, so this is Juana, and this is Diego, okay? The question, if Juana is pulling at 23 pounds of force, okay, that's not pound like weight, that's pound in terms of force. It can be a unit of force as well. Diego is pulling with 27 pounds of force, and that you can see the angle measurements. So the prediction I want you to make, and there's not necessarily a right or wrong right now, you don't know, it's just a prediction, is would the dog end up closer to Juana or closer to Diego? And we're assuming that they're starting off equal distance from the dog. So would the dog end up closer to Juana or closer to Diego? You can turn a message in the chat. It's very close. It's all right. You're sending a message in the chat. What is your prediction that the dog would end up closer to Juana or closer to Diego? Okay. I like your answer, Jimena. All right. So here's how we would solve a problem like this. We want to think about it as 2 vectors separately. So I'm going to call Juana vector A. I'm going to call Diego's vector B. So we're going to write it out. Vector A And I like to do when I draw it, I like to draw it as a dashed X and Y coordinate plane. So that when we draw the actual vector, it's easy to tell what we're looking at. Okay, so I'm gonna draw vector A. I'm gonna do a dashed coordinate plane. And vector A is Juana's. Okay. And then I'm gonna draw the vector with an angle of 18 degrees. And this is 23 is the magnitude. So this is the vector A for Juana. Okay, so I'm just drawing it on its own coordinate plane separately. Then I'm going to draw a vector B. Okay, and the angle, and vector B is diagonal. The angle is 15 degrees. And the magnitude is 27 pounds of force. Okay. And then what we want to do with that is we want to find what is the component form for vector A and the component form for vector B. When we say component form, remember that's A comma B. So that's what we're trying to find for both of these. So we're finding what is a horizontal component and what is a vertical component. Or in other words, this would be our A and this would be our B, or the horizontal component of the force and the vertical component of the force. Based on the information that we are given, how do we find the A? From a couple classes ago. Anybody can unmute themselves and share. How do we find the A for vector A? Hello?
You can do cosine, right? Cosine of, well, for vector A, you can do cosine of 18. What is it? X over 23.
So yes, but then when you end up solving it, the simple equation that we could remember is just what will go out here in front.
Oh, the 23.
Yeah.
Okay.
So you could do the cosine, but you end up with always getting magnitude, right? It's magnitude times cosine of the angle, right?
Yeah.
Okay. Comma, and then for the B, it's magnitude times
Sine.
magnitude times sine of the angle, right? That was what we did on IXL, how we found the A and B when you have magnitude and when you have an angle. And then that part we would put in the calculator, okay? Making sure the calculator's in degrees. I have my calculator here. This is a calculator I used in high school. The TIE3 doesn't have NSOL or anything like that. So 23 cosine of 18 is a 21 point. I'm just gonna round to 3 decimal places. 21.874, and then you'd find 23 sine of 18. That's gonna give us 7.107. Okay. So what that is that is the horizontal and the vertical components of Juana's vector. Okay. So that is saying, like, if you were to write A and B on this graph, this would be 21.8 whatever, and this would be 7. It is the A and the B of that vector. It's important that we understand what we are finding and what that is. Okay. So that's the A and B of Juana's vector. We're going to do the same thing with Diego. Find the A by magnitude times cosine of the angle. Now here's where you have to be very careful. And I would write a note to yourself on the notes, because this is, if you do this part wrong, when you're dealing with the angles, it'll mess up everything. And there's several of these word problems here. So it's very important to know. What we do not want to do is write 27 times cosine of 15. okay? We see this angle is 15, and we talked about this before, but we don't want to write 27 times cosine of 15. Because if we put cosine of 15, then the calculator is assuming that we are in what quadrant? The first, exactly. So we want to be very careful with your angles here, because cosine of 15, if we think about in standard position, that's 15, right? And that's going to change completely what it is, because this would be positive, right? But this is positive, negative. So you just want to be very careful with your angles, and I will write a note to yourself there. So instead of 15, that's why I would kind of try to point out the angle from the horizontal, you will put this angle. So the calculator recognizes what quadrant you are in. So it's going to be 345. Or if you wanted to do negatives, you could put negative what here instead. But then that would also work to recognize, the calculator will recognize that you were in that quadrant. You can put negative what? Hello? What else could you put here instead of 345? And the calculator will recognize where you are. So this is the positive angle.
Negative 15.
Yeah, you could put negative 15. That's fine, because negative 15 would be recognizing we're going in this direction. That's negative 15, okay? So that's important to know. All right. So then comma 27 times sine of 345, okay? So we're just gonna put that in a calculator. 27 times cosine 345 is 26.079. 27 times sine of 345 is negative 6.988, okay? And I always like to go back and double check that what we have for A and B matches with the graph. So this is saying, we're saying this is the A, so it goes to the right 26. We're saying this is the B, so we're saying it goes down negative 6.98. And that matches with the graph. If this was a positive number, it doesn't match with the graph. So you just want to double check. Okay. So what we did there is we found this is the component form of vector A. So this and this. This is the component form of vector B. So this and this, the two components, okay? What the original question is asking is, what would be the direction and the angle of the resultant force? And resultant is when you add, right? So resultant is A plus B, okay? So now we're gonna do here vector A plus B. So we are going to be adding these two using what we talked about last class. We're adding those two to combine to find the resultant. So you would just add 21.874 plus 26.079. So that's 47.953. That's your A. Then you would add the B's, 7.1077 plus negative 6.988. That would be 0.1197. Okay, so that is vector A plus B. Then you want to do a visual of that. And so you can see if the A is 47.9. Am I going too fast? Are we good? Let me pause for a second. Okay. If the A is 47.953, we're going to the right. That's our horizontal component. Positive, so we're going to the right. 47.953. The B is 0.11, so we're going up very slightly. And so our resultant A plus B vector is this. This is A plus B. Based on that, that's telling us that we're going to be closer to Juana. The dog will be closer to Juana or closer to Diego. Slightly, very slightly. Kevin, where are we going to be closer to? Kevin? Oh, I see the message in the chat. Gotcha. Juana, yeah, because it's slightly up, right? And Juana is up. Okay, so we need to find the magnitude and the direction. Let's start with magnitude. Magnitude is the square root of a squared plus b squared. That's the equation for magnitude. This comes from the Pythagorean theorem. So it's the square root of a is 47. We're finding the magnitude of a resultant. So 47.953 squared plus 0.1197 squared. And that part you would use a calculator for. I'm getting 47.95 pounds of force. That is a combined force of Juana and Diego pulling on the dog. Okay. And for the direction, the equation for direction is tangent inverse of B over A. So it'll be tangent inverse of 0.1197 divided by 47.953. And that is going to give us 0.143 degrees. That is our direction. So this angle right here, it's very small, very slightly going to be going up towards Juana, 0.143 degrees. So less than 1 degrees of the dog going towards Juana. Okay, so that is how you would find the combined forces of two people in this context pulling on an object. In this case, a dog. Questions? A lot there. This is kind of the combination and the application of vectors here. We're going to do several problems on this. Any questions? Okay, let's try another one. This is the problem that I kind of showed you at the beginning. If you remember, and I said this is a problem we'll be able to do. So we had a father and a son that are using two ends of a rope to pull the stump of a tree from the ground. The father pulls on one side with a force of 20 newtons at a 70-degree angle with the ground. The son pulls on the other side with a force of 15 newtons at a 50-degree angle with the ground. And the question again is asking for the direction and the magnitude of the resultant force. Okay, so we will first start with vector A, and we would draw it. We would do vector B. We would draw it. And so this over here is the father, because it says the father is doing 20 newtons. This is the son, because it says the son is pulling at 15 newtons. So vector A we'll say is the father. And we're going to draw that 70-degree angle, 20 newtons, 70-degree angle. And vector B for the son, we'll draw, we're over here, 15 newtons with a 50-degree angle. Okay. And then we'll do the same thing. We'll find the component form. So magnitude times cosine of the angle. So 20 times cosine of 70 and 20 times sine of 70. And over here be, well, actually, we'll do that one later. Let's finish this one. Now, is it okay that I put cosine of 70? Is that accurate? Or do we need to like change that? Do we need to consider what quadrant we're in? Or is that okay? Because you always want to be careful with the angles. Is that angle okay? All right, so I see in the chat y'all saying it's okay. All right, good. So then I put cosine of 20 times cosine of 70 is 6.84. 20 times sine of 70 is 18.79. And I always want to go back and see, does that make sense in the visual? Does it go to the right? That's positive, yes, 6.8. Then it goes up 18. That makes sense in the visual. Okay. Now do the same thing for vector B. 15 times cosine of 50. 15 times, oh, I made a mistake, right? What's my mistake here?
The angle should be 130 instead of 50.
I saved all the money too.
Exactly, yes, very good. Because if I say 50, then that's saying we're over here. Hey, buddy. If we say 50, then that's over here. So we're using this angle, 130. All right. And then 15 times sine of 150. So be very careful with the angles. So 15 times cosine of 150. I'm sorry, 130. That's a 130. I'm sorry. 130. As I said, be very careful with the angles. 130. 15 times cosine of 130 is negative 9.64. And 15 times sine of 130 is 11.49. Okay. And I always go back and I say, okay, does that make sense in the graph? So this is negative, so now the A is left. That makes sense. Positive is going up. That makes sense. So that would be good. Let's say, by the way, that in this, instead you put 50. That would just change the negative and the positives, and then you'll be able to see what's wrong there. Okay. Okay, so we're trying to find if both the father and the son pull this tree, what will be the direction and the magnitude. So now we would add vector A and B, right? So we're adding, change the color to purple. These two, we're adding these two. That's going to be negative 2.8 over here. And this would be 30.28. That's vector A and B, those two combined. And then we're going to sketch just a graph of it. To the left, negative 2.8, up 30.28. So that is vector A plus B. That is a resultant of both of them pulling it. Right? So now because it's slightly to the left, we can see that this is slightly going to be like that. Okay? All right, so now we need to find the actual magnitude, right? So the magnitude is the square root of A squared plus B squared. So it's the square root of negative 2.8 squared plus 30.28 squared. Now let's put that in the calculator. I'm getting 30.4, and that's Newton. So this is the combined force in the resultant of both the father and the son pulling. And one just way to double check is that you know that the number has to be greater than these two. Okay. All right, direction is tangent inverse of B over A. So the B is 30.28 and the A is negative 2.8. Right? Wait, I need tangent inverse on this, sorry. So tangent inverse of 30.28 divided by negative 2.8 is negative 84.71. Now, this is an important thing to talk about. So I'm going to pause, give everyone a minute to catch up and write if you need to write why that angle is negative and what that means for how we write direction. Okay. Let me pause though and ask, are there any questions so far? No? Okay. At this part right here, negative 87.4, negative 84.71, we talk about direction. It is important to note, if we include a negative when we're doing tangent inverse, sometimes our result angle will be negative. Okay? All that means, if we think about what angle did we find, okay? We found this angle right here in the triangle, right? Because this is opposite, this is adjacent, and we found this angle right here. If it was a regular triangle, you would have no negatives. It would just be, you do tangent inverse of whatever the side length is over here and the side length over here. Because we're working on the coordinate plane and we're in the second quadrant and we're including negatives, then sometimes our answer here will be negative. All that means, if you remember what a positive and a negative degree is, positive means we're going in this direction. So positive degree. Negative means that we're going in this direction. That's a negative degree. So if this angle is negative, we're still talking about this right here. All that it means is that instead of going this way, that would be a positive angle. We're going this way. That would be a negative angle. Okay? So for the purposes of what we are doing with vectors, the negative doesn't necessarily matter when we're talking about direction. Okay? It's important to note why it's negative, so you know. But when we're finding the direction, it doesn't matter where I talk about it from this side, that's negative, or I talk about it from this side. All we need to know for this problem is that this angle is 84.71. This angle right here, right? And what we're doing is we're writing the angle from the horizontal, so we need this, right? And so it would be 180 minus that 84.71, not minus negative. You would do 180 minus 84.71. Okay, and so that would be 180 minus 84.71 would be 95.29. That would be the angle from the horizontal. Okay. All right. Now, what that looks like in this context here, if we think about this A plus B being slightly to the left of being directly vertical, that'd be like this right here, would be our A plus B, right? And if you think about what we talked about before with the parallelogram method, this is not a perfect drawing, but just in general, is that like if you were to draw the parallelogram method, that would be that should be your resultant, right? Which should match what you have here. That is those forces being combined. Okay? So that's how you do word problems of vectors. Let me pause. This is kind of this is the first lesson. So you know how we had 2 lessons that we're doing today. This is the first lesson of the 2. So are there any questions on this part here? All right, I like the thumbs up reaction. Maria, you could do that too. If you're good, you could do the reaction with the, no, I'm good. Okay. All right, well, let's talk about the second one then. So, this one, the second one, this is what we were traditionally going to do tomorrow, but then y'all voted on doing 2 and 1 today. This one is on applying vector situations, specifically when it comes to direction of, like, let's say direction of a plane in the air, navigational direction of a boat in the water, things of that nature, okay? So when you describe the angles of these, it's slightly different. There's multiple ways you could describe the angles. So that's what I want to talk about here, okay? So let's say that you have, this is north, this is east, this is south, and this is west, right? Okay. And you're trying to describe this angle right here of 60 degrees, okay? There are 3 ways that you can describe this angle. One of which we've talked about is horizontal. So we can say, we can talk about it with respect to that angle, which is, that would be 270 minus the 60, because 270 is this whole thing. So we could say this would be 210. So we could say 210 degrees from the horizontal. That's the way that we've been writing them. If we're doing it in navigational terms, then it's slightly different, okay? So if we're doing in navigational terms, it's gonna look something like this. So like this is an example of a navigational way of writing, okay? So what comes here, this is not the exact angle, I'm just giving you an example. This is where you start, and this is where you're going. So what I mean by that is if we're looking at this, here we are starting at south. So a way you would write this is you would say south, and then you are going 60 degrees towards west. So south, and then 60 degrees towards west. That's how you would write that in navigational terms. Where you're starting and then where you are headed towards. So you would read this as like 60 degrees west of south. You have to talk about where you're going, like you're going west, but like where are you going west from? Because you could be going west from north, right? Or you could be going west from south. So you have to specify, are you going west from south or west from north? Because there's 2 different ways you can get to west. So that's why you have both of those there, okay? Or let's say we were talking about this angle here. Let's say we're coming from this way. Then we will say we're going, we're starting at west, and we are going, in this case, we'd be going 30 degrees towards south. So that would mean 30 degrees south of west. Okay. So that's how you would write that in navigational terms. So let's try the one in the middle together. I want you to try the one on the right. This is just kind of pre-knowledge you need before we get into the problems with vector solving, okay? So this one has 140 degrees from the horizontal. That's already given to us. This angle right here, so if this is 90, and the angle right there is 50, right? And this is north, west, south, east. So if we're writing the 50 degree with respect to the 50 degrees, it's starting at north and is going 50 degrees towards west. Okay. Or if we're over here, and let's say we're talking about this angle, that's starting at west and going, that would be 40 degrees, going 40 degrees towards north. So 40 degrees north of west. Okay. My N's and my W's look very similar. This is a W, and this is an N, sorry. It's a W, it's an N. Okay. All right. So y'all try this one, saying we're assuming that this angle is 68 degrees. So if that angle is 68 degrees, write that in 3 different ways. I'll give you a few minutes to try that. And Anna, you can click, there's a way you can click pause record so the video doesn't take up too much.
Okay, so for the first one, I did from the horizontal. So you could just say 292 degrees from the horizontal by subtracting 360 minus 68.
Okay, very good. Thank you. Jimena, could you give me the second one that you did?
I did south S 68 degrees and then east because it's going towards east.
So you did south and then 68 degrees east. So just to clarify, this angle right here is the one that is 68, right? So like if this is east and this is south and this is north, it looks weird because it goes all the way around. I don't know why, but so like in this case with the 68, that one is starting at what? Like if we're going from here to here.
It's starting at east.
Mm-hmm. So it'd be starting at east because that's where we're starting over here and we're going towards this, and it's going towards south because it's pointing to south. All right. Does that make sense, Samantha?
Yes.
Okay, cool. So like the south going to east, that would be this angle right here. And that one would be how many degrees? It's hard to write. So if that's south going that way, that would be how many degrees there?
22.
Say that again.
22.
22. And so that would be starting at south, going 22 degrees east. Okay? Because you're pointing, where you're pointing to comes last. Where you're starting from comes first. So that's just how you write the angles in navigational terms. Okay? Last kind of knowledge to know is bearing. Okay? So with rotational angles, that is what we are used to. Those are angles measured in degrees. As we're going this way, it is a positive angle. That's rotational angles. Bearing, when we're using navigational terms for ships and airplanes, if you use this if you see the word bearing. If you don't see the word bearing and you see like this, these terms, you're not starting necessarily from the north. Only if you see bearing. Then bearing is described as degrees clockwise from north. So this angle right here would be considered a positive angle. Let's say this was 50 degrees. That's 50 degrees. So you would say it has a bearing of 50 degrees. So that's kind of like a special case. We're talking about navigation for ships and planes. If it says bearing, we're starting from north and going right. And that's counterintuitive because that's different than everything we've talked about, because going this direction usually is a negative angle, so it's different. So bearing is a special case, okay? So here's another example here. Bearing of 200, you're starting at north and you're going in this direction. And it is considered positive even though traditionally it's negative, okay? So just to make sure we're clear on all of the ways, let's say you were writing this one, that would be 135 degrees from the horizontal. That's one way to write it. Or you can write it with respect to this. That's north and that's west. That small little angle would be 135 minus the 90, right? So that small little angle would be 45. So the other way you could write that is starting at north and going 45 degrees towards west. So north going 45 degrees west. That's one other way to write it. Or you can write it as this angle, which is west, And that's also 45 degrees. So west going 45 degrees towards north. Okay. If it was described in terms of bearing, we would be starting at north and we would be going this direction, right? That's bearing. That would be a bearing of, that is going to be 360 minus this 45. So a bearing of 315. Those are the ways you can describe an angle when we're talking about navigation or airplanes or ships, okay? When you would use which one really just depends. It is not a right or wrong. It depends on, if you have multiple choices, it just depends on the answer choices. If you're solving a problem, if it's specified that is bearing, you use bearing. So it just depends on what you're doing. Any one of those ways is appropriate if it's not specified. Any questions about that?
So, even if it's going that way, and we would usually say it would be like a negative 315 would be positive.
Yeah, for bearing, yeah.
Okay.
Other questions? Okay, so let's try a problem. We're gonna do 2 problems together, and then I'm gonna give you 1 problem to do on your own. All right. So this one says an airplane flies east for 200 miles before turning 60 degrees south and flying for 100 miles. What are the magnitude and the direction of the airplane from its starting point? So on this question, I always want to start with drawing a visual. Okay, so you have an airplane. It's an airplane flying east, so that direction, for 200 miles before turning 60 degrees south. So we're starting at east and we're turning 60 degrees south. So if it was to keep going east, it would be like that, but it turned. So then this angle is it turning 60 degrees towards south, doesn't go direct south, 60 degrees towards south. And then it flies for 100 miles. It's a visual of that. And the question is asking, what is the magnitude and the direction of the airplane from its starting point? So here's where it started, here's where it ended. We're trying to find this. That would be magnitude and direction from its starting point. Okay? Now, there's 2 ways we can do it. We're going to do one that we've been talking about, and then I want you to think about the other way you can do it. So we can think about this as 2 vectors. This is vector A. This is vector B. What would this be considered then? Would it be vector C? What could we, just looking at that visually and connecting to what we've talked about in prior classes, what would that vector be there?
Vector A plus vector B.
Yes, very good. That'll be A plus B, because this is the head to tail method of adding vectors, right? Remember from last class, like if you have this vector A and this is B, this is A plus B. That's the head to tail method of adding vectors. So what we would do here is similar to what we've been doing. We would find vector A component form. We would find vector B component form. When we add them, it will give us that red line we have there, which is vector A plus B, and we can find the magnitude and the direction of those. So similar process. So start with vector A. Always draw a visual first. Vector A, easy. It just goes to the right 200. So in component form, our A, which is our horizontal component, would just be 200. And our B, which is our vertical component, it does not go up or down. So it is just 0. 200, comma 0. Doesn't go up or down. Vector B, it goes like this for 100 miles. This angle was 60. And that one we would have to do the formula. Magnitude, which is 100, times cosine of, we need to be careful with the angle here. We can't put 60. If we put 60 here, then the calculator is assuming that we're over here. So we need to put, you can put the whole 300, or we could put negative 60. So cosine of 300, and 100 times cosine of, or sorry, sine of 300. All right. Good so far? Now, I know that this is 50. Why do I know that's 50? Just connecting to prior knowledge. Think about that for a second. Why do I know that's 50 off the top? And this one is negative 86.6. So how do I know that's 50?
Because cosine of 300 is half.
Very good, yes. Cosine of 300, that's from the unit circle value, that's a half, and a 1/2 is 50. Yes. Okay. Then we're finding vector A plus B.
Okay, thank you.
So we're adding these two. Adding this plus this. So 200 plus the 50 is just 250. 0 plus the negative 86.6. Negative 86.6. That is the component form of vector A plus B. I always like to draw a visual. To the right, 250. Down, negative 86.6. So this is A plus B. Now, before we kind of find the magnitude direction, it's always good to look back at your original and see, does it match? So like this, if you look at it, it is pointing generally in the same direction. It should be, if we were to draw the exact measurements out, it should be exactly what we have there, okay? Bless you. I think you have your volume on it.
My bad.
You're good. So magnitude is the square root of a squared plus b squared, and we're using vector a plus b, so it's a and b. So 250 squared.
Let's go, finally. God damn.
So you're going to do the square root of 250 squared. Natalia, I think you have your volume on actually. Plus 86.6 squared. And that's going to give you 264.57. And that is our distance from the airplane here to the, from a starting point to where it is then. And so that would be we can eliminate C and A, because this matches up with our magnitude here and here. Okay, pretty cool. Now for direction, we're looking at now, here's that east and south, right? So we would do tangent inverse. B over A, so that would be negative 86.6 over 250. So that's giving me negative 19.1. And then remember, the negative, wouldn't be so concerned with that. Just looking at the triangle we have here, this angle is the 19.1 degrees. And we can see here that this is the only one with 19.1, but we need to make sure that our east-south kind of matches up, that we're talking about the right one. So if this is starting at east, let's write that bigger. So we had this, that's kind of what it looks like. It's 19.1. So we're starting at east, going towards south. So east, then 19.1 degrees, going to south. So yes, that is, wait, not that one, I'm sorry, this one. Yes, that is correct. So that is how you get. So by knowing the planes, by knowing how the plane went forward 200 miles, then turned for 60 degrees, went for 100 miles, you can know how far away the plane was from where it started to where it then is, and what direction from where it started to when it is, the angle is. So that's how you would use the vectors to solve this problem. Any questions? No? I have a question for you if there are no questions. What is another way that you can find this answer other than what we did? If you didn't know vectors, if you didn't know vectors, if I erased all of this and you didn't know how to do vectors, what is another way we could find this?
Cosines?
Say that again.
Log cosines?
Very good. Because you know, you would be able to find this angle, right? That would be 120, right? And you could use the law of cosines to find this, and it would work as well. Because you have a side here, you have a side here, you have the angle, you could find this side. And then to find this angle, then you would use what? After you find this side using law of cosines. You could find this angle using what?
Law of sines?
Law of sines, very good, because you have angle and you would have an angle and a side opposite of each other at that point within a triangle. So it is possible sometimes to use some of the other trigonometry that we know. Okay. All right. If there are no questions, let's try one more. I want to do one more. Just kind of with the bearing, just to make sure we understand the concept of bearing. And then I'll probably give you one to try on your own, just to make sure you feel 100% comfortable with it, since we did kind of 2 in 1. All right. So it says a charter boat leaves port on a heading of north 60 degrees west for 12 nautical miles. The captain changes course to the bearing of 25 degrees for the next 15 nautical miles. Determine the ship's distance and direction from the port to the current location. So similar type of problem, you're finding distance and direction from where, in this case, a boat started to where it ended, but now just the angle measurements are different and the distances. So let's start with this. North 60 degrees west. That means we're starting at north. So let's say the boat is over here. It's the boat. Going north 60 degrees west. This is north. This is west over here. So we're starting at north, going 60 degrees towards west. for 12 miles. Let me put this a little bit smaller. Y'all good with that? Okay. Then we're going at a bearing of 25 degrees. So that's where you're starting at north and going to the right. So if we're here, here's north. Because we're doing a bearing of 25, that's going from the north east. So this is 25 degrees. That's the bearing. And we're doing that for 15 miles. And then what we're looking for is from here to here, that's A plus B. That's what we're trying to find. So we could do law of cosines on this one as well, right? Because we could find this angle. Actually, we can't find that angle, no, because in this case, it's not 100. It's not going to add up to 180. So we can't use law of cosines because there's no way to find that angle right there with the information we have. So we would have to use vectors. The other one was possible because of the way that the angle worked. It added up to 180. Okay, so let's call the green one vector A. We'll call the red one vector B. Always start with the visual. So vector A, this is 12, this is 60 degrees. Vector B, this is 25 degrees, and this is 15. Okay, I'll give you a second to write that down. All right, so then it's going to be this one. You need a component form, so it's 12 times cosine of, keep in mind with your angle there, your angle is not 60, you need to do it from the horizontal. So your angle would be cosine of 90 plus 60. Cosine of 150. 12 times cosine of 150. Oh, sine, I'm sorry, this should be sine. Times sine 150. I'll use a calculator. That is a unit circle value, but we'll use the calculator for the cosine. Wait, 12 times cosine of 150. So that's going to be negative 10.39. This one will be 6. Okay. And this one over here would be 15 times cosine of, keep in mind your angle. You need to use the angle from the horizontal. That's 90 minus 25. Cosine is 65. And 15 times sine of 65. That's 6.34. This one is 13.59. Okay. Now what? Give you a minute to catch up, but now what do we do next? We got our component form of vector A and vector B. Also, I forgot to mention this. We always want to make sure that they make sense, right? So like this is negative, so make sure it goes left. This positive, it goes up. That works. Positive, positive goes right and up. Just make sure that it works. But what now?
You added two components.
Very good. So we need vector a plus b now. So we're adding these two. So negative 10.39 plus 6.34. That would be 19.5. And then we draw it just to get a visual. So it goes to the left, negative 4.05 and up 19. So this is vector a plus b. And did we do something wrong? Reason why I'm thinking maybe we did something wrong is just because I always like the visual that helps us. This one is going to the left, and this one is going to the right. But all that means is what? I don't think we did something wrong. So all that means is that, or did we do something wrong? You tell me. Or did we do something wrong? Oh, it's good to go back and look at the visuals. So did we do something wrong or we're good? Looking back at the work. Why does the visual not match? Y'all still with me? Hello? You can send a message in the chat or unmute or say, I don't know, I'm not sure.
Well, my idea is since like the 25 degrees, the bearing of 25 degrees for the next 15 miles is starting from where you ended the first vector,
Mhm.
and they don't start at the same origin.
Mhm.
That's probably why it's like that.
You talking about this right here?
Yeah. I'm
So,
not sure.
so can you say one more time what you said?
So like the 25 degree, the bearing of 25 degrees for the next 15 nautical miles, it starts from the end of the first vector. It's not starting from the same origin. So it's like, that's probably why it's like that. I'm not sure.
Okay. So it does have to do with the 25 degrees. I'm not sure what you mean by the starting from the next vector, but it's simply that the graph is not drawn to scale. And so I wanted you to just kind of take note of that, to be careful with that, because the 25 degrees really it should be a little bit smaller, right? And so if we drew it a little bit smaller, it would be something like that. And then vector a plus b would be going in that direction. And so as you're kind of comparing your final a plus b with your original, if it's not as drawn to scale, you just want to be careful not to think you did something wrong. That's what I wanted to point out here. Is just because that wasn't the 25 degrees wasn't drawn like an accurate 25 degrees. Okay, so it did have to do with that 25 degrees. Okay, so magnitude is the square root of a squared plus b squared. So we're using a plus b. So it's negative 4.05 squared plus 19.59 squared. So we can put that in the calculator. That's going to be 20.004. So we'll just say 20 nautical miles. So that is going to be this, if we were to draw this accurately, that 20 nautical miles is this. The distance from where the boat started to where the boat is. And then tangent inverse of b over a to find the direction, 19.59 divided by negative 4.05. I get negative 78.31. And then remembering the negative, not as concerned about that. We know that the 78 is referring to this angle. It's negative because it's going up instead of down, but it doesn't matter so much here. That's 78 degrees. So when we describe that, we would say that that is 78 degrees. We're starting at west and is going 78 degrees towards north. It's pointing to north. That would be the direction. That would be the distance. So that is using vectors applied in context of navigation.
How can we determine what direction the angle is going?
So in this problem, because you don't have like, if I'm understanding your question correctly, because you don't have like an answer choice where it specifies, you could say it's west 78 degrees north. You could also say that it is north going 12 degrees west. You can use any of those because in this particular context, you're not talking about the direction that the plane is going, like here, or the boat is going here, where you were starting away and then you went a certain way. This is talking about the direction of from where the boat started to where the boat ended. What's the direction of that? So like if the boat was here and then it ended here, it's not like you're not describing where it was and then where it turned. It's just what's the direction from here to here. So you could describe that using this angle, you could describe that using this angle, you could describe using this angle. It doesn't matter because there's no answer choices and because you're not starting and then you're like turning from somewhere, similar to like how these were starting somewhere and headed to somewhere. It's okay, you can use either of these or you can even use the horizontal, all would be considered fine. If I'm doing the problem, I just use the 78 because it's already given here and I don't have answer choices, so that's just the easiest to use since we already had it there. All right. Any other questions? Okay. This is the last problem that I want you to try by yourself, but first I want to talk about practice, just in case if anyone has another call that you need to go to, just to be respectful of your time. So we'll talk, if you can stay and try that problem, then we'll go over after so you can make sure that you're right. Just talk about practice real quick. I was working on the practice this morning as a key, and I was noticing there's like 15 questions because it's 2 practices in one basically, but I just posted it as one worksheet. I was noticing it was taking me a little bit of time just because you have basically like kind of like there's some review, but then there's some of these questions and they take a little bit of time. So as an extension, I spelled extension wrong. As an extension, if you need more time, that's totally fine. Like if you want to, because there's no school Friday, there's no school Monday, and I don't think I'll be grading them over the weekend. I probably won't get to grading them until next week. So if you need to turn it in on Monday or if you need to turn it on Friday, if you need some extra time, that's totally fine. Just we didn't want to throw that out there. If you have like other work, I know it's the end of the 6 weeks and you might be catching up on grades for other classes too. So if you need more time on this practice, you can Monday. Let's do Monday. Will be the latest date that it could be turned in, and then for the IXL though, from Monday that should be turned in by Thursday. Okay, and these grades go into next 6 weeks, not into this 6 weeks. Okay. So any questions about that? Any questions about general stuff before we do that last practice problem? And Anna, you could pause or actually, let me switch it to this slide. And then Anna, you could pause the recording.
Mr. T, I don't think we can hear you.
Thank you. I have myself on mute. What did I say? Oh, I said take a minute to compare your work with this, and let me know if there's anything that you got different or have questions on. If you need to take a screenshot, you can take a screenshot. This will be uploaded on YouTube as well. If you need to refer back to any part of this lesson. Thank you for being patient with my technology issues at the beginning. On if you could stay after just for a minute so I can talk about how you can send me the video that you recorded. Thank you for sticking through. It was a longer lesson. We did 2 and 1. So really the next Zoom will be Thursday. If you need to join, there's going to be office hours. It's just answering questions if you have any over the practice. That'll be Thursday at 10. It is not mandatory. However, it's encouraged. If you have any questions, I usually just go over the problems. Also, if you need to confirm if any problems are correct, I usually do that as well by checking answers. And then you have a 4-day weekend if you celebrate Easter. Hope you enjoy that. And then on Tuesday, we'll start a new lesson, and that will be a new unit. Like I said, kind of the pre-calculus is segmented. From here on, the new unit will be on conic sections, so ellipses, hyperbolas, things like that. Tuesday's lesson will be a shorter lesson, and then Wednesdays will be a little bit longer. Tuesday's lesson, if you can come prepared, if you have a laptop, you can have a laptop with you. There's going to be a software that I want you to kind of navigate and work with. which it's not a software, it's online website. So that's for next class. So that's a week from now if you're not joining on Thursday, so you have quite a bit of time. And again, for the practice, you have until Monday if you need the extra time for it. If you want to just get done and have a nice 4-day weekend, no work, that's also totally fine. In the group chat, if you can send a message 1 through 10, 1 being, I want to do this a little bit more since I'm not able to kind of get feedback through seeing y'all, your reactions to whether you're understanding or not. Usually I can tell if you have confused faces, which next Zoom, I'd like for you to be prepared to have your video on so it can feel more like a class, especially considering the fact that we might not be in class for potentially the semester. So if you could take a minute and in the group chat, 1 through 10, 1 being you struggle with this lesson just based on the notes so far, 10 being I got it, I feel comfortable with it. Okay. So take a minute to send that in the chat, and Anna, you can pause the video.